Hello. So I just wanted to make a recording to go over what we did in class today because I know a lot of you missed the notes or you were getting bumped in and out. So I thought I'd just review them really quick. All right. So what we have going on here is we're solving two-step equations. And the big idea here is that we're trying to find that value for x that right there that would make the left side equal to the right side. And the right side is -7, so the left side would have to be -7. Okay, and so we're looking for that number that would make that whole value -7. Okay, so that is the whole point of what we're doing. And so a couple things to remember. So this, you should remember some of this from last year. Remember. We have these over here. This is something, the steps that we'd used last year, and it's the same notes. If you look through your stuff from last year, you could probably find a copy of it. Okay, I made it a little bit smaller, but it's just the same thing. We're going to eliminate the constant, then we're going to eliminate the coefficient, and then we're going to check it, and then we're done. Okay, so that's what we're going to do. The number one goal of what we're trying to do is to isolate the variable. So that is that once we're finished with this eliminate the coefficient, that should be what has happened. That should be alone. Okay. Number two, we want to keep in mind that this is an equation, so we need to maintain balance. So that is another one. Okay, and the process, another thing that we do a lot to try to find out what that was, is to undo operations. And I'm running out of room here, so I'm squeezing. So undo operations. Okay, so let's take a look at this first problem. That's 9x minus 7 equals -7. So we have our x here, and we need to get that alone. So that means that everything that's on this x side needs to go to the other side. And the way we're going to do that is opposite operations. So basically what that means is that everything on the side of the x we're trying to eliminate. To eliminate, we're going to go, you remember PEMDAS, so we're actually, because we're undoing stuff, that implies that we're kind of working backwards. Okay, so the first thing we're going to undo is the add and subtract. Okay, and so we're going to go ahead and get rid of any kind of add and subtract on that side. So I have -7. So the way to undo minus is to add. So add 7, add 7. So now what's the point of that? The point of that is to make this 0. It's eliminating that -7 on that side. So we're making it 0. I cross it out. I could write 0, but whenever I do that, I write 0 like that. It just literally kind of makes the thing look funny. So I don't do that. Okay, and so then I have 9x left on this side equals, and then -7 plus 7. Oh, well, that doesn't happen all the time, but there's nothing wrong when it does. So 9x equals 0. Okay, so x isn't alone. So we've gone through the eliminate constant stage. Now we need to eliminate the coefficient. We have x, but we still have a number in front of x. So we're going to do that. 9 times x times, we're going to divide. We divide both sides by 9. That gives us 1, or 1 right here, which we know in visible math, if you have 1x, you're just going to have x, equals 0. Now, some of you probably could have looked at 9x equals 0 and thought, oh, 9 times 0 is 0. I got it without having to do the division. But really, theoretically, you did do the division just in your head. Okay, so x equals 0. Well, why do I know that works? Because if I replaced it, instead of x, I'm going to write 0. 9 times 0 is 0 minus 7. 0 minus 7 is going to be -7. So I have shown that the left side is equal to the right side. So there's my check. So I like to do my check just to make sure. Okay, so that's the first problem. Okay, so that's example 1. Another type of problem you're going to run to is very similar. Again, we have the A. It's on the right side. So that means that all the stuff we're going to eliminate is going to be on that right side. So I have to eliminate. Okay, so we're on our next problem now. We have 6 equals a over 4 plus 2. So on the A side, we're trying to get rid of the plus 2 and the divide by 4. Okay, so eliminating the plus 2. So we're going to do opposite operation, inverse operation. So plus 2 minus 2, that's 0. So we've eliminated that on that side. A over 4 equals 6 minus 2 is 4. So now this is where it's a little bit different than the last problem. We're still going to do a multiply, undo a multiply or divide, but in this case it's divide. So to undo divide, we're going to times by 4, and that reduces and becomes 1. Again, that invisible 1, 1a is going to be a. And then multiply by 4, and I'm going to get 16. Okay, and so just to double check that, and just to make sure that we have it, 6 equals 16 divided by 4 plus 2. 6 equals 4 plus 2. Yep, 6 equals 6. So there's our check. So we've done our check. We've shown that A is going to be 16, and we've shown that that is the right answer. Okay, so these next problems are a little bit different. So when you look at 2n plus 5 minus 2, well, the parentheses here are a grouping symbol. That grouping symbol says that I cannot do anything with that plus 5 yet until I have done something with the 2. So we've got a little bit of reversal. Again, it's that, please excuse my dear Aunt Sally, we usually do parentheses first, but we can't, so we need to do something with the 2. Okay, now in this case, this is kind of an easy fix. So I can just recognize that that's a 2 times. So I can undo the times. So I've got 2 times n plus 5. So I'm going to divide by 2, divide by 2. Again, remembering that this is the n, so we're trying to eliminate everything on that side. Well, n divided by 2 divided by 2 is 1. So I just have n plus 5 equals, and the negative 2 divided by 2 is negative 1. And notice the whole step along the way, we're keeping things balanced by doing the operations on both sides. So I've got my n, and now I've got to get rid of the 5. So minus 5, minus 5. That's 0. N equals, make my 2 marks, negative 1 plus negative 5 is negative 6. I can check my work. So 2 times negative 6 plus 5 equals negative 2. This is going to be negative 1. And then 2 times negative 1 is negative 2. And that's what I had on the other side. So that is a good check right there. Okay, so n equals negative 6. Okay, so everything I'm doing over here on this right side right here is just simply showing that the answer that we got works. Okay, I had one more question here, and I think it's n plus 9 over 3 equals 8. Now this is a little different again, just like this last one, because of the grouping symbol. So the grouping symbol here, because it is under the n and the plus 9, they're both, it's like kind of like on the parentheses. So I cannot do anything with the n plus 9. I have to do something with the 3. And so I'm going to go ahead and do something with that 3. I'm going to multiply by 3, and again, it reduces to 1. Keep it balanced by doing this. Now, what I've done is, again, n is here. I'm trying to eliminate anything else. So I've eliminated the 3. So n plus 9 equals 24. 8 times 3 is 24. Subtract 9 from each side. Keep it balanced. That eliminated the 9. N equals 15. So 15 plus 9 divided by 3 equals 8. That is the original problem. Oh yeah, that's 24 divided by 3. Yeah, that's 8. Check mark. So all done. And that is the notes for today. And try to get these uploaded, but good luck with that. See you at office hours, and let me know if you need any other help. Thanks.